Scientists just accomplished something once thought to be impossible. They captured an actual photograph of a planet orbiting a different star, not an artist's rendering, not a simulation, a real image of a world sitting 100 light years from where you are right now. Once you understand how this image was made and what it means for the future of space exploration, it's going to be hard to fully wrap your head around it. This is just another space headline. It's the start of something every generation before ours could only imagine. Stick around, because by the end of this, your mental picture of the universe is going to shift permanently. Right now, over 5,900 planets outside our solar system have been confirmed. Nearly 6,000 worlds. We know for certain exist some larger than Jupiter, some smaller than Earth, some rocky, some gaseous, some circling two suns at once, like something out of a sci-fi film. Decades of work went into confirming all of them. Here's the wild part. Almost none of those thousands of planets have ever actually been photographed. Most were discovered the way you locate a lamppost in a pitch-black room, not by seeing it, but by noticing someone's silhouette pass in front of it. Astronomers watch a star and wait for a tiny momentary dip in its brightness. That flicker tells them something crossed in front of it. For decades, that shadow watching was the best method we had. That's exactly what makes this new achievement so remarkable. The James Webb Space Telescope didn't detect a shadow or a flicker this time. It captured an actual photograph, a direct image of a planet circling another star. And not just any planet, this is now the lightest, smallest exoplanet ever directly photographed, shattering the previous record. The planet is named TWA-7b, orbiting a young red dwarf star called TWA-7, also known as CE Antlia, about 111 light-years away in the constellation Antlia. That distance sounds massive by human standards, and it is, but on a galactic scale, it's essentially our next-door neighbor. The observable universe spans 13 billion light-years, so this system is practically on our doorstep. TWA-7 itself is remarkably young, only around 6 to 5 million years old compared to our sun's 5 billion years. It's still surrounded by a swirling disk of leftover dust and debris from its formation. Ground-based telescopes had already revealed 3 distinct rings within that disk, separated by gaps. Those gaps mattered. In planetary science, a gap in a debris disk is usually a sign that something with real gravitational pull is carving a path through the material, like a planet acting as a cosmic lawnmower. Astronomers suspected a hidden planet was responsible, but actually spotting one inside a debris disk is one of the hardest challenges in the field. Picture trying to spot a firefly hovering next to a massive searchlight. The light overwhelms everything, and the firefly's tiny glow disappears completely. That's the challenge with planets. Next to stars, stars are so overwhelmingly bright that a nearby planet becomes nearly invisible, like a candle flame beside the sun's surface. This is why direct imaging of exoplanets has been so difficult for most of history. Webb carries an instrument called MIRI, the mid-infrared instrument, which includes a coronagraph, essentially a precision-engineered device that blocks out a star's light. So whatever's hiding near it becomes visible. Think of it as putting your thumb over a flashlight, except vastly more sophisticated. Webb's coronagraph uses a 4-quadrant phase mask that splits incoming light into sections and cancels the starlight through destructive interference, a genuinely advanced piece of optical engineering. Even with that suppression, some starlight inevitably leaks through, so scientists still need to clean up the data afterward. A team led by astrophysicist Dr. Anne-Marie Lagrange of the French National Center for Scientific Research in Paris ran the raw data through processing algorithms that mathematically stripped away the remaining stellar glare layer by layer. What emerged was a faint but distinct infrared source, sitting exactly in the gap between the disk's first and second rings. Webb first observed the TWA-7 system in June 2024, revealing that faint object right where the gap was. But the team moved carefully. Could it have been a background galaxy coincidentally in the frame? After calculation, the odds of it being anything other than a planet were about 34, less than a third of 1%. The evidence pointed overwhelmingly to a real planet. The team published their findings in Nature on June 25th, 2025, and the astronomy world lit up almost immediately. TWA-7b has an estimated mass roughly 100 times that of Earth, about 0.3 times Jupiter's mass, putting it in the same weight class as Saturn. It's a gas planet, not a rocky one, and not somewhere you'd want to visit. What makes the mass so significant is historical context. Every exoplanet ever directly photographed before this one was substantially heavier. The previous lightest was still 10 times more massive than TWA-7b. This single discovery represents an entirely new, much lighter category of planet we can now actually observe. The The planet orbits roughly 50 times farther from its star than Earth is from the Sun in our own solar system. The distance would place it out beyond Neptune. Its estimated temperature is around 320 Kelvin, about 47 degrees, or 117 degrees Celsius. That might sound warm, but for a planet still radiating heat left over from its own formation, it's actually quite cool. A young world still glowing from its birth. This marks the first time a planet has ever been directly observed sitting inside a debris disk. Astronomers have long theorized that gaps in these disks are carved out by planets. Gravity, a foundational idea in planet formation theory, but it had never been directly confirmed before. TWA7b sits precisely where the math predicted a planet should be to explain the gap, offering direct visual proof of the mechanism. There's also an intriguing side note. Webb's data hints at a small cluster of dust-sharing TWA7b's orbital path, similar to Jupiter's. The Trojan asteroids here in our own solar system. If confirmed, this Trojan disk would be the first such structure ever spotted around another star, a bonus discovery layered onto an already major one. You might wonder why a Saturn-mass planet around a dim, distant red dwarf should matter to you. Here's why humanity has chased the idea of other worlds for centuries. Galileo pointed a primitive telescope skyward in the early 1600s and spotted Jupiter's moons, proving the cosmos didn't revolve entirely around Earth. In the 1990s, astronomers confirmed planets exist around other stars, and for decades afterward, we found thousands more, always indirectly, one flicker of starlight at a time. We knew these worlds existed. We just couldn't see them. Now we can. Webb has shown that pointing a telescope at a nearby star, blocking its glare and photographing a planet directly, not some giant gas world several times, Jupiter-sized, but something in Saturn's weight class is achievable. And if a Saturn-mass planet can be photographed today, the natural next question is, when can we photograph something smaller? Dr. Lagrange has spoken about her hope of eventually directly imaging Earth-like planets. That goal now feels far more attainable because the technique has been proven and the method understood. Astronomers expect Webb to keep pushing towards smaller, less massive planets in the years ahead. But truly, Earth-like worlds will likely require even more power than Webb offers, which is where the extremely large telescope ELT comes in. Under construction in Chile's Atacama Desert, the ELT will have a 39-meter primary mirror, making it the largest optical telescope ever built once it comes online around 2028. Combined with Webb's capabilities in space, the next T-decade could bring actual photographs of potentially habitable worlds. Webb, meanwhile, hasn't slowed down since launching in 2022, and it has already helped identify more than 100 exoplanets through the transit method. Detected molecules like carbon dioxide, water vapor, and methane in various atmospheres, and picked up intriguing, though still debated atmospheric signals from the distant world K2-18b. It has also peered back toward the universe's earliest galaxies and revealed star-forming regions in unprecedented detail. But TWA7b stands out even within that track record. This was the first time Webb set out specifically to directly image a planet found one nobody had seen before and successfully photographed it. Prediction, observation, confirmation, and publication all came together. Consider what an image actually is. Light that traveled from somewhere entered a lens and was captured. The infrared light in this photo left TWA7b and crossed 111 light-years of spacelight that began its journey before the Wright brothers ever flew. Before the telephone existed, before electric lighting, that ancient light eventually reached Webb's mirror, was processed and cleaned, and now sits ready for scientists to study. And notably, TWA7b itself is a particularly dramatic planet. It's not in a habitable zone, it's not rocky, it's a cold gas giant sitting in a debris disk. Scientists targeted it not because it's extraordinary, but because of what it proved about planetary formation and imaging techniques. It's the proof of concept evidence that the method works, paving the way toward eventually imaging genuinely Earth-like worlds. The observable universe spans roughly 93 billion light-years and contains an estimated 2 trillion galaxies. The Milky Way alone holds somewhere between 100 and 400 billion stars, and most of them likely host at least one planet. The sheer number of worlds out there is nearly incomprehensible. For most of human history, we didn't even know these worlds existed. Then we found shadows and flickers of light. Now, with a telescope orbiting 1 million miles from Earth, we're beginning to actually see them. TWA7b is the first planet directly discovered by Webb through direct imaging, a moment that will likely appear in astronomy textbooks for generations. Some of today's schoolchildren will grow up to operate the instruments that finally capture the first genuinely Earth-like world around a nearby star building on the foundation Dr. Lagrange and her team established. Every time humanity has pointed a more powerful instrument at the sky, we've been stunned by what we found. Galileo's telescope upended the idea that everything orbited Earth. Edwin Hubble's observations in 1923 revealed that fuzzy smudges in the sky were actually entire distant galaxies, instantly expanding our sense of the universe's scale. Hubble Space. Telescope's images, starting in 1990, showed that even seemingly empty patches of sky were packed with thousands of galaxies. Webb is doing this again in real time within our own lifetimes. Since its Christmas Day 2021 launch and subsequent deployment, Webb has repeatedly exceeded expectations from its first full-color images in July 2022 to ongoing atmospheric studies of distant worlds. What it accomplished with TWA-7b represents something categorically different, not analyzing starlight filtered through a planet's atmosphere during a transit, but actually seeing the planet itself as a distinct glowing object in space. That distinction matters enormously. Most planets never pass in front of their star from our vantage point, meaning transit-based detection simply doesn't work for them. Direct imaging has no such restriction. If a planet is bright enough and the coronagraph powerful enough, it can be found regardless of its orbital position. That's a massive expansion of what's possible to study. Right now, as you read this, Webb is somewhere out there, gathering more photons, building images of things never seen before. Somewhere in that incoming data, there may already be the next TWA-7b waiting to be found.